Okay, geometries, this is Mr. Bloom, and we are working on notes for section 2.1. Now you just got a new notes packet for chapter 2, and we're going to be working on the skills for proofs. Okay, and these are basic skills. These will be used for the next 3 chapters, and all the stuff from chapter 1 will be used as well. So let's get started. We got lesson 2.1, patterns in inductive reasoning. Make sure you're getting your objectives written down. To use inductive reasoning to make conjectures. If you need to turn it off, make sure you get it written down in the box. When I went through notes, I noticed that people aren't completely filling things out, and the things they don't completely fill out are the things they have the most questions on. Now, across the page on the back side of your the copy that came in is our formal scale for chapter 2. Okay, now keeping in mind all this stuff is stuff we're going to be going through in chapter 2, and we're going to be able to recall and check things off. Now as we finish each day, you should come back to the main page and check off what you learned that day. If you have questions on an item that you heard about and thought you learned but are questioning, you got to make sure you follow up with one of the geometry teachers. So inductive reasoning is reasoning based on patterns you observe. Problem 1, finding and using a pattern. Look for a pattern. What are the next 2 terms in each sequence? Okay, so I've got 2 sequences here. Okay, I've got 3, I got 9, I got 27, I've got 81. Now, you just keep looking up as you're going and think about what the next sequence is, okay, and fill it out. In this particular case, I'm multiplying by 3s, so it should be 243, and then multiply that by 3, 729. Now, that was a sequence that we were able to find from multiplication. Let's check out the B pattern. I've got a circle with 3-sided figures, a circle with 4-sided figures, and a circle with a 5-sided figure. What are the next 2 terms in the sequence? Go ahead and give it a try. Okay, hopefully you're seeing that it's a circle with 6 and a circle with 7 sides. So it's 1, 2, 3, 4, 5, 6, and this is 1, 2, 3, 4, 5, 6, 7. Okay, now it's your turn to figure out if you got it. Can you answer these 2 questions? What are the next 2 terms in each sequence? Shut me off and turn it back on when you have your answer. I want the next 2 terms. Now, what are the next 2 terms? I go 45, 40, 35, 30, 25, 20, and that's where I should be going down by 5s. In this next one, I have a square, a rectangle with no rectangle on its side. Okay, that's my first one, a rectangle with another rectangle, and so it's really 2 rectangles, and I'm twisting it each time by 90 degrees. And then I have 3 rectangles in my third one. I should have what and what for my 4th and 5th ones. So 4 rectangles and 5 rectangles, turning 90 degrees at a time for each vertex. Our next one, conjectures, a conclusion you reach using inductive reasoning, or it's a conclusion based on, it's an educated guess conclusion. So in a conjecture is you look at what's happening and you make a prediction of what's going to happen next. If we wish to find the 100th term of a sequence, we would rather find a pattern and make a conjecture instead of finding all of the first 100 terms. So when we look at this, using inductive reasoning, look at the circles. What conjectures can you make about the numbers of regions 20 diameters form? Now keep in mind, we would like you to make a conjecture of what you see here and what you see here and what you see here. And instead of doing the next 17, make a conjecture, an educated guess based on these 3 items, what the 20th what conjecture can you make about the number of regions 20 diameters form? How many regions will 20 diameters? This is 1 diameter, 2 diameters, 3 diameters. Okay, so when you do this, make some notes. 1 diameter is 2. 2 diameter is 4. 3 diameters, 1, 2, 3, is 1, 2, 3, 4, 5, 6. So 6. Okay, now with that information provided, how many, because what we're going to do is I'm going to skip a few. So if I have 20 diameters, how many regions will be formed? Diameters, 1, 2, 3, diameter is 20. Take an educated guess. Hopefully you see 40. Now, what conjecture can you make about the 21st term? The 21st term in RWB, RWB, RWB in the 21st term. Turn me off, figure it out, go. Okay, welcome back. Now, the 21st term is a factor of 3. So if I use, a multiple of 3, I should say, not a factor. 3 is a factor of it. So if I look at these first 3, so 3, 6, so B's are going to be 3, 6, 9, okay, 12, 15, 18, and 21 will be B. Hopefully you recognize that. And it's because of that pattern of 3s that helps us. Going on, reasonable conjectures must be made based on observed patterns. Can you make a reasonable conjecture about the sequence 1, 3? Now, based on 1 and 3, you have ideas. And several people probably have different ideas on different things. This could be 5, 7, 9, 11 because we are looking at odd numbers. That may not be the only conclusion that can be found, but because we have 2 numbers. The third number would probably help this out. So just keep that in mind. There might be others. So you try this one. Can you make a reasonable conjecture about the sequence 3, 8, 11? Turn me off, try to figure it out. Okay, welcome back. We got 3, 8, and 11. And I'm looking at 3. 3 is 5 apart. 8 is 4 from 11, or 3 from 11. So I've got 5, 3. Maybe this next one's 1, and it's 12. But I also see 3 and 8. And if I add 3 to 8, I get 11. If I add 8 to 11, I get 19. If I have 11 and 19, I get 30. If I add 19 and 30, I get 49. And that's the one I see. Okay, so depending on the pattern you see, and you can support it with your conjecture, okay, perhaps we can write it down. Remember, a conjecture is an educated guess. Okay, what do you think will happen? So keep in mind that is based on observed pattern and reasonable conjectures based on observed pattern. Now, number 3, collecting information to make a conjecture. What conjecture can you make about the sum of the first 30 even numbers? The first 30 even numbers. And what's that mean? So if I talk about if I add the first 30 evens, so the first one is 2, then I have 2 plus 4, and that's 2 numbers. Then I've got 2 plus 4 plus 6. Then I've got 2 plus 4 plus 6 plus 8. Okay, that's the first 4 even numbers. And now I got to keep in mind, I'm going to be working with and get this to 10. So I'm going to copy this or clone it. and say, all right, I got those, and I'm going to add plus 10. Now let's talk about what these sums are. Okay, so let's look across, and I've got sums coming across. Let's see if I can make some straight lines here. My little table to help us out. So I've got 2, I've got 6. And this is my first one, my second one, my third one, my fourth one, my fifth one, my sixth one, and then I'm going to add this, and it's going to be 12. And then I'm going to get to 20. And then I'm going to get to 2, 4, 6, 8. I forgot 10 here. And this is 12. So this is 30. And this is 42. Now at this time, you should kind of have a pretty darn good idea what's going on. Okay, I have a conjecture that my first one times 2 is 2. My second one times 3 is 6. My third one times 4 is 12. So the first 3 is those 3 times 4 is 12. My fourth one is 4 times 5. You starting to see this? Is 20. My fifth line, my 5 units, if I just multiply by 6, I'll get 30. So my first 6 even numbers will sum to 6 times 7, which is 42. So I'm thinking the conjecture I'm looking at, what conjecture? If I want to go the first 30 even numbers, it'll be 30 times 31. And that'll be the sum of the first 30 even numbers I have. And if I take that on a calculator, it's going to be 930. So make sure you check me out, because that's 30 times 31, and that's 930. So 930 would be the sum of the first 30 even values, even numbers, the first 30 even numbers. Okay? Now, what conjecture you make about the sum of the first 30 odd numbers? The first 30 odd numbers. Now, notice the grid I made. I would like you to make a grid to have a plan and see what's going on. Okay, give it a try. Shut me off and try it. Okay, welcome back. What conjecture can you make about the sum of the first 30 odd numbers? Well, the first one's 1, right? So the first one is 1. The second one is 4. The third one is 9. The fourth one is 16. The fifth one is 25. Okay, and the sixth one happens to be 36. Now I want to make sure you realize the first odd numbers, the first 2 odd numbers added together, the first 3 odd numbers added together, the first 4 odd numbers added together, first 5 odd numbers added together, and the first 6 odd numbers added together. Well, this is just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. So 6 squared. So in our conjecture work, we have a pattern that we've come up with. I'm not going to do all of them, but I pretty much know that the first 30 odd numbers will sum to 30 squared, which equals 900. Okay, so that's how we do our conjecture work. We investigate information on a smaller number, and then we project our educated guess, our projection of our conjecture. Our educated guess is our conjecture on the answer, so we can know that that is the sum of the first 30 odd numbers, is 900 in this case. Okay. Now, problem 4, making predictions. Sales of backpacks as a nationwide company decreased over a period of 6 consecutive months. What conjectures can you make about the number of backpacks the company will sell in May? Now, if I look at this is my backpack sales diagram. I've got my NDJFMAM. Now, you got to keep in mind what this means. November, December, January, February, March, April, and May. Now, they're asking up here in this problem, I'm looking at what backpacks will they sell in May? And let me get that graph up a little higher. That's unlocked. So we're going to get that graph up here. So we're looking at this, and what conjecture you make about the number of backpacks the company will sell in May? Well, in May, this is April, this is May. We don't have this. We have information of best fit line. You guys kind of went through that last year. If we talk about best fit line, a best fit line is a line that fits the data, approximates the data's pattern, and we try to make that fit as we go down. So that looks like it's something that's going to go down, but remember this part of the graph, I've got to keep in mind, this is skipping a little. So this is 8,000 right there. So I'm skipping 8,000, okay? So from 0 to 8,000, this is 8,000, then it goes up every 500, okay? Now, when I'm looking at this, I'm going to be selling less backpacks in May than I did in April and so on. It's a downward trend. And in May, I'm about 500 less than April. About 7,500 backpacks will be sold, okay? So just keep that in mind when I'm looking at this graph. Now, I put a best fit line to kind of give me that trend line, okay, to have us give an idea, because that's really what I'm doing. I'm asked to predict based on a trend. So I'm going to group that, and I am going to bring it down for us to answer the next 2 questions here. And I want you to answer these 2 questions. What conjecture can you make about backpack sales in June? Okay, go ahead and talk to your row partner about it. And if you're at home, talk to yourself in the mirror. Pretend you're your own row partner. You know, the me, myself, and I row partner. Okay, so June, you know, based on our data we have, in June it's probably going to be less than it was in May. So we're predicting 500 less than May, so about 7,000 backpacks maybe as it goes down, and the trend keeps going. Okay, but there could be some other reasons that we could come. Well, in June, people are on vacation, and so more backpacks will be sold, or might be a blip of backpacking backpacks for people going on trips. So there is some information that we may or may not have, but right now we know during the school months, you've probably come up with this idea of a conjecture that during school months, we are definitely not having as many backpack or a high backpack need in May or June as we would in you know, the fall, like September, November, you know, October, November, December. So we got to be thinking about that as we consider the time of year. Now look at B. Is it reasonable to use the graph to make a conjecture about sales in August? And explain. Go ahead and talk to your row partner, or you make your own conjecture and we'll talk. Now, my thought about this one is that there will be 1,500 more are sold in August than in November because they are ramping up for school. I'm predicting, you know, just based on my line trend that up here, that if I consider August way up here, and if I unbold this or ungroup this, if I take my line and I bring it up here and I let it extend up, that back here, if I move this back in August, there'd be a lot more backpacks sold, you know, assuming that it was a linear downward trend, about 12,500, okay? Now, we follow established patterns to make our conjectures. Remember, conjectures are educated guesses based on patterns, but we may be wrong. Be sure to test your conjecture several times. Now, when you're wrong or you discover an outlier in your conjecture, your educated guess doesn't work, then wormy it, work on it, re-establish another idea of it, adjust your conjecture so it works in all situations. If you find even one example where it doesn't work, then it is not true, and this is called a counterexample. The one example where it does not work is called a counterexample. Keep that in mind. Okay, that is an example where it proves your conjecture to be false, although it works in a lot of other situations. So the counterexample is a big deal. Now, in problem 5, I'm telling you right now, we're finding a counterexample. That means I'm pretty much telling you the conjecture I'm reading is wrong. You got to find why it's wrong. So number 1, if the name of a month starts with the letter J, it is a summer month. And I'll have people going, yeah, June, July, those are totally J's. All J's are summer. But what J isn't summer? January. January starts with a J, but is not a summer month. Okay, at least. The next conjecture that we're looking for a counterexample on, you could connect any 3 points to make a triangle. Now, I've got people putting dots on their paper right now. Yep, I can put 3 dots on the paper, I can connect the lines, I can make a triangle. What if the points were, I don't know, collinear? And people are like, 1, 2, 3. If these 3 points are on the same line, they can't make a triangle. It's 3 points that aren't in line that can make a triangle. So we have to fix our conjecture. Your turn. When you multiply a number by 2, the product is greater than the original number. And product is the result of a multiplication. So when you multiply a number by 2, the product is greater than the original number. Think about it. Talk amongst yourselves. When is this wrong? Can you think of an example? Both are not greater than the original number 2 if one is 0 and the other is 2, or if one is negative and the other is 2. So those are 2 examples where that would not be true. Now, let's see if you got it. I want you to answer the next 3. Okay, these next 3. Turn me off, answer the next 3, and then turn it back on. Okay, so welcome back. Got it. What is a counterexample for each conjecture? Remember, conjecture is an educated guess. If a flower is red, it is a rose. That means all red flowers are roses. But you know, I saw a flower that was red that wasn't a rose. That's all I have to do. I got to come up with a red flower that's not a rose, and that's a counterexample. And that is a carnation. It's red and it's not a rose. One and only one plane exists through any 3 points. That's true, so long as they're not collinear, and we don't say that. So if they're collinear, when the 3 points are collinear, there are an infinite number of planes through those 3 points. Okay? When you multiply a number by 3, the product is divisible by 6. Now, only if that number had a factor of 2 in it would it be divisible by 6. So 3 times 2 becomes 6. Okay, you can make that happen. But that is not always true, because 3 times 5 is 15, and 15 is not divisible by 6. Okay, I hope that's working for you. I hope you're understanding that stuff. Remember, a conjecture is an educated guess based on patterns that you've seen, and you're trying to extend those patterns over. And a counterexample is where you can find all the things that are not right with your conjecture. You know, if you can prove it wrong, proof is wrong, proving a conjecture wrong is a counterexample. Our summary today: use the lesson objectives and your notes to reflect on what we learned today. Our objectives: to use inductive reasoning to make conjectures. Now check out your stuff. See what we can check off today. Okay. See, we converse, inverse, law of syllogism, inverse, converse, properties of congruence, vertical angles, condition report, none of things in 3. Axioms, theorems, defined terms, undefined terms. Hypothesis, conclusion, negation. Do we have conjectures in here yet? Doesn't seem like we have a conjecture here yet. There's conjecture. Do I have counterexample in here? Counterpositive, counterexample. I've got inductive reasoning. I know what complements and supplements are already. Okay, so I am just reading through, checking off the things I definitely know. And maybe even read through right now today, check off the things you know from other chapters as well. I know vertical angle theorems. Properties of congruence, use algebraic properties, prove a conditional, nope. Okay, I've got them done, okay? All right, you got today's assignment. Go off to it and let's get her done. Have a great day.